Okay, next is the beginning of our section on unit conversions. And in this, we learn how to, say, take a measurement and change the way it's expressed. This very simple example of unit conversions would be like changing something from inches to feet. We've probably all done that to some extent anyway. And so, everybody knows, hopefully, that there are 12 inches in a foot. And so if you have a number of feet and you want to know how many inches it is, you multiply by 12. If you have a number of inches and you want to change to feet, you divide by 12. And that's essentially the idea behind any kind of unit conversion. The way we state, basically the way that we do unit conversions takes the form of what's shown down at the bottom of the page there under the first unit conversions page in the math handout. Only I'm going to phrase it a little bit differently because I think it might be easier to remember that way. Basically, when unit conversions are about converting measurements from one unit to another. When you do that, of course, the number associated with the unit also changes. Okay, it's time to go to the Sharpie store, I think. Problem is the ones that write really well soak right through the paper. And when we're doing unit conversions, as the name implies, we're keeping our attention mostly on the units to make sure the units work out correctly. But it's important to keep in mind that the number is also going to change. Every measurement consists of a number and a unit. It's also a handy tip to remember when doing unit conversions, at least between units that you're familiar with, is that if the unit gets bigger, the number should get smaller. And vice versa. If the unit gets smaller, the number should get bigger. And that's because the quantity that's being measured remains the same. So if you're going to be measuring it in smaller units, it's going to take more of them to equal that quantity than if you're doing it the other way around. If you're using bigger units, that's going to take fewer of them. If you think of just feet in inches, 1 foot is 12 inches. Inches are smaller than feet, so it takes more of them to equal the same distance. So a distance of 1 foot, which is 1 in terms of feet, would be 12 in terms of inches. So unit gets smaller, number gets bigger, vice versa. And in this sense, it's a lot like scientific notation, where we kept repeating over and over again, we're not trying to change the value of the measurement, we're just trying to express it in a different way. And in fact, we're trying actively not to change the overall value of the number, just trying to say it in a different way. So that's something to sort of keep in mind as we're doing unit conversions. And one handy thing about unit conversions, though, is that algebraically, you do the calculation, and if you're keeping an eye on the units, and you make sure that the units come out correctly, not only that the units make sense, but the units are what you want them to be when at the end of the calculation, then the chances are that the numbers will work themselves out also. So watch the units, and the numbers should follow. The usual form for a unit conversion will involve a measurement involving some units that's given. And of course, when I say, so I'll represent that as units given. Of course, this measurement would have a number associated with it also, but like I said, we're going to watch the units and get the equation arranged so that the units work out correctly, and then we can come back through with our calculator and multiply or divide the numbers out. So the units given are what you'll start with. This will what will be given in the question, and then you have to multiply by a conversion factor. And that conversion factor takes the form of a ratio. One part of the ratio will involve the units that you're starting out with in the question, that is the units given, and the other part of it will involve the units that you're going to, that is the units that you want. The conversion factor is derived from what you could call an equivalence statement. And so an example of an equivalence statement is just 1 foot is equal to 12 inches. It's just a statement of two quantities that are equal to each other, only they're in different units, so there are different numbers involved too. But in principle, these two measurements are the same thing. They represent the same quantity of distance, 1 foot and 12 inches. So when you have the equivalence statement like this, one part or one side of this equivalence statement is going to become the numerator when you turn it into a conversion factor, and the other part is going to become the denominator when you turn it into a conversion factor. With the way we're writing this equation now, what that means is that since you want the units that you're being given to cancel out, and you want the units for the question to change to another unit, you want the new units on top and the old units on the bottom. So you want units given on the bottom and units wanted on the top. That way, you'll notice that any quantity that exists on its own as just like, you know, a number like 3.5 inches, you can consider that to be in the numerator of a fraction divided by 1. It's because you can divide any number by 1 and without changing the value. So that means that units given is in the numerator in this term, while units given is in the denominator in this term. Well, when you multiply or divide units, they act just like numbers. So when you take a number like, say, 2 and divide it by itself, 2 divided by 2 is 1. In effect, the numbers cancel out when you divide them by themselves. The same is true of units. Units given divided by units given will cancel out. And what's left is units wanted. And that is in the numerator, which is where you normally want the new units to be when you're doing a unit conversion. So units given times conversion factor with units wanted over units given equals units wanted. And that's the general form that conversion factors take. A couple of really simple examples here. So say if you want to convert .4 inches to feet. Okay, we know that we're going to need a conversion factor. And so we know that 1 foot is equal to 12 inches. This conversion is, like I said, it's a nice, easy one that we can start with. And so it can be done in one step. Theoretically, any unit conversion from basically any units to any other units can be done in one step if you know the right conversion factor. But even with Google at your disposal, it might take quite a while to find certain conversion factors. So what we use, the usual custom is to remember a few important unit conversion factors, and to have a few others available to you, like on the, there actually is an entire list of equivalent statements in the last page of the math handout, and you can use that for doing just about any of the problems we encounter. But unless you know an infinite number of conversion factors, a lot of conversion problems are going to have to be done in more than one step. And so you take the original units, you convert them to some other units, then you take those units and convert them to other units, and then you take those units and convert them to the units you want. But we'll get to those later. That's getting complicated. Right now, we'll stick to ones that can be done in one step. So hopefully everybody knows that 1 foot is equivalent to 12 inches. The conversion factor sheet at the end of the math section handout here has conversion factors mostly between the metric system and the English system. Conversions within the metric system are handled just by knowing the values of the metric prefixes, and conversions within the English system, I guess they just don't consider those to be very important for the world of science, since we all pretty much use metric now in science, so they're not included either. But any questions that require conversions within the English system, I'll make sure that it's something simple like inches to feet, so that it'll be something that everybody will know. So we take the units given along with the corresponding number. So it's 3.4 inches, multiply by a conversion factor, and hopefully we will get out feet. The conversion factor is going to be made from 1 foot is equal to 12 inches. One side of the equation goes on the top of the conversion factor, the other side goes on the bottom, and we just have to decide which is which. We start out with inches as the unit, and that's equivalent to being in the numerator. So we want inches to be in the denominator. The unit we want for the answer is feet, so we want that unit to be in the numerator. So there's your conversion factor, 1 foot for every 12 inches. Now inches should cancel, leaving us with feet for the unit of the answer. And I didn't actually do this, so I'm going to do it now. 3.4, the number, well, now that we've worked out the units and made sure the units come out correctly, the number will probably come out correctly too. And all you have to do is take basically 3.4 times 1 divided by 1 times 12. Now, obviously, you don't have to include the ones because they don't change the values of anything. So in essence, all you really have to do is take 3.4 divided by 12. You want to make sure to divide by 12 because it's in the denominator. And when you do that, you get 0.283 repeating on to infinity. All right, for now, actually to be perfectly correct about things, you would also want to abide by significant figures. 3.4 inches has 2 significant figures. When we write it as 3.4 divided by 1, that 1 is considered an integer, and that would be an exact number, so that's an infinite number of significant figures. And the 1 foot over 12 inches is a definition. Conversions within the English system are definitions, and they have infinite significant figures. So both the 1 and the 12 are infinite in significant figures. The same is true for any conversion factors within the metric system. So like 1 meter equals 100 centimeters. Those numbers are both considered exact and infinite in significant figures. But conversion factors between the English and metric system are not exact, and you have to count significant figures for those. Because when we say that, say, 1 inch is equal to 2.54 centimeters, that's really only an approximation. If you wanted to be more accurate, you could look it up and you could take that 2.54 out to many, many more places. That number keeps going forever. Because the metric system and the English system are based on different things, so the units don't line up evenly. You know, you don't have even numbers of correspondence between the units. So anyway, these are very badly drawn infinity sign, infinite. So 2 significant figures is what we should be having in the answer. So 0.28 would be our answer. Okay, so that's how we do it in this case. If we had say a number of feet and we wanted to know how many inches it is, well, we would just use the same conversion factor, only we would use it upside down because we're going backwards with the units. So you want the opposite unit to cancel out and the opposite unit to be your answer. So 12.6 feet, and this time you want feet on the bottom and inches on the top because we want inches as the answer. This is going to be just 12.6 times 12. You can ignore the ones in the denominator. And that's 151.2. Now, for significant figures, that's 12.6 is 3 significant figures, and 12 inches over 1 foot, that's a definition that's entirely within the English system, so that's infinite. So 3 significant figures it is. That means we have to drop the 2. 2 is less than 5, so it doesn't affect the numbers before it. So our proper answer would be 151 inches. And remember, feet cancel out. It's as I emphasized, as I've been emphasizing all along, it's very important to keep an eye on the units because if you make sure that the units come out correctly, you can make sure that the numbers will come out correctly in most cases. Because suppose we tried this instead. I'm going to write not up front just to make it very clear that this is not the way you want to do this. But suppose you had 12.6 feet and you wanted to go to inches, just like the last example we did. But suppose you use that conversion factor between feet and inches the wrong way around. You had it as 1 foot over 12 inches. Well, when you go to work the units out and you realize that 12.6 feet is in the numerator, you're going to have feet in the numerator times feet in the numerator. That's square feet over inches in the denominator. Not only are these units not the units that you wanted inches, but square feet per inch means nothing. It makes no sense. There's no such thing. So you definitely don't want to do it this way. And that's why I said, keeping an eye on the units can help you avoid making mistakes with the numbers also. Okay, so like I said, watch the units and make sure that they come out right, and you should be okay. Let's see, the unit conversion sheet here, I'm doing things a little bit differently than they're presented there. For one thing, the unit conversion sheet jumps right into converting cubic units, which I would rather leave until a little bit later and do some simpler stuff first. So number 1 is a problem statement converting 19 cubic inches to cubic centimeters. And because it's cubic, I think I'm going to skip that and come back to it. Number 2, which is way over on the next page, is convert 750 feet to meters. Okay, if I can find a pen that will actually write. Okay, and then it's making you write out everything sort of explicitly as to what's what. The original measurement is, of course, 750 feet. The original unit, or unit given as, the way I was writing it, would be feet. The target unit, or the unit that you want, would be meters. And the conversion factor is actually, if there are actually practically an infinite number of ways that most unit conversions can be done. Some of them may involve more steps than others do, but that doesn't make them wrong. So we're not going to grade you on your unit conversions based on using the fewest steps possible. As long as you're using valid methods and valid conversion factors, you could do it basically any way you want. I mean, don't be ridiculous about it and use 100 steps, although that would be possible. You could probably do that with a lot of unit conversions. But generally, we try to do it in as few steps as possible just because that saves some work. Anyway, one of the conversion factors on the last sheet in the math handout says that 1 meter is equal to 3.281 feet. That allows you to do this in one step because feet and meters are the units that you want for this problem. So all you have to do is use one conversion factor. So in this case, we have our units given, which would be 750 feet, and that's equivalent to being over 1. And we have our conversion factor made from the equivalent statement, 1 meter is 3.281 feet. Now here we've got feet in the numerator, so we want the feet to go in the denominator. So 3.281 feet in the denominator and 1 meter in the numerator. Notice now that feet will cancel, and we end up with meters being the only unit that's left for the answer. For the number, you have 750 on top in the numerator and 3.281 on bottom in the denominator. So, and the other numbers are 1. So essentially, all you have to do for the calculation is take 750 divided by 3.281. And I get 228.5888449 meters. Now, as you might guess, that's a little excessive in terms of significant figures. I don't even think I want to count how many that is. That's basically everything the calculator spewed out at me. So remember, calculators don't know anything about significant figures. So you're going to have to work the significant figures out on your own. Let's see, this number here, 750. Note that the original number 750 did not have a decimal point. That means 2 significant figures, the 7 and the 5. Zeros at the end don't count if there's no decimal point. The conversion factor is between metric units and English units, so these are not exact number. Well, actually, the 1 meter is an exact number because you're saying basically how many feet are there in exactly 1 meter. So the 1 is exact, but the 3.281 is not. That is 4 significant figures. Of the 2, 2 is smaller, so 2 significant figures it is. So we have to change 228 point whatever down to 2 significant figures. That means the 2 and the 2 can stay, but everything else has to go. The first number that you're dropping is an 8. That is above 5. So that means the number before it has to go up by 1. So 2, and the second 2 becomes a 3 now, because the first number we're dropping is an 8. And the 8 was before the decimal point, so when you drop it, you replace it with a 0. And do not write the decimal point in, because 230 with no decimal point has 2 significant figures, just like 750 with no decimal point. but if you put the decimal point in, it's going to have 3 significant figures. And don't forget the units. So there is the correct answer to the proper number of significant figures. Okay? Okay, well, I see we're just about up to a half an hour now, so I'm going to leave it there. We'll pick up with some more examples in the next lecture. This lecture I'm only going to do 3 parts for also, since don't want to go too fast on these things, since a lot of you are probably just learning it or seeing it for the first time in quite a while. So I'll give you some time to practice. I will post the homework soon, and I'll see you in the next lecture.